All right, class, welcome back to our unit on similarity where we continue ratios and proportions. This is the last installment of the lesson for this. I've gone in great detail because it's so important to completely understand what ratios and proportions are before we get into the algebra behind it and even the geometry behind it. So if you have not watched the first two videos for this, please watch this video, or watch them before getting to this video. So we are finishing up. We're going to talk about extended ratios and solving proportions in this lesson. So these are all the things we've already covered. I talk a lot because I want to make sure that we understand stuff. So make sure you've seen them. Otherwise, stuff is going to get pretty tricky. So we're going to start by using proportions. We talked in the last lesson about what proportions are and how we can structure them. And in this lesson, we're going to use them. So here's a fundraising example. Members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. And they plan to buy 120 pots of flowers. That's a good thing to have. The ratio of the number of tulip pots versus the number of daffodil pots will be 2 to 3. Okay, so there's going to be 2 tulip pots to 3 daffodil pots. How many pots of each type of flower should they buy if the total is going to be 120? Now, there's actually 2 ways to approach this. The first way is through guess and check. Okay, so there is a guess and check method. The next way is through algebra. So the first way, let's do the guess and check. So how would that work? If we take the ratio, the number of tulip pots, the number of daffodil pots, and we do it one time, that means we'd have 2 tulip pots and 3 daffodil pots, right? But that would only be a total of 5. Okay, so the total would be 5, and clearly that can't be it because the total flowers is 120. So what would happen if we redid this like a second time? What if we try and do this 2 times? Okay, so if we're doing it 2 times, how many tulip pots would we have purchased? We would have purchased 4 of them. Okay, 4 tulip pots, and we would have purchased 6 daffodil pots to keep the ratio the same. Okay, so we would go from 4 tulip pots and 6 daffodil pots to keep the ratio of 2 to 3 the same, but that would give us a total of 10. And that can't be because the total is 120. Now you can keep doing this. Okay, so let's go 3 times, right? What's going to happen? Well, 3 times 2 is 6, and then 3 times 3 is 9. That's 15 total. That ain't it, right? So, let's jump a little bit. What if we did like 10 times? If we jump a little bit, we do 10 times, we have 20 tulip pots and 30 daffodil pots. That would be 50 total, so that ain't it. Man, this is crazy, right? So what might it be? Maybe we can go to 20 times even, right? So if we expanded this 20 times, and remember what this was called from previous lessons. This is called the scale factor. Okay, so we are increasing by a scale factor of 1, 2, 3, 10, 20 times now. So anyway, 20 times 2 is 40 tulips, and 20 times 3 is 60 daffodils. That's only a total of 100. So we're getting closer, right? You can guess and check. We're getting closer. How about 22 times or 21 times, right? So 21 times 2 would be 42, and then 21 times 3 would be 63. Okay, so that's 105. Well, that ain't it. So we can keep going, right? So maybe, I don't know, like a nice cool number like 25 times, right? So we can guess and check and get there. Anyway, 25 times 2 is 50 tulips, and 25 times 3 is 75 tulips, or 75 daffodils. That's 125, right, total. So darn it, we went too far. So let's back it up a little bit. 24 times, right? So if we did 24 times 2, that'd be 48 tulips. And then 24 times 3, that would be, 72 daffodils. And 72 and 48, guess what? 120 total. So you can do this by guessing and checking, right? but that's the math behind it. So we had the scale factor of 24. So what this means, just so you know, what this means, 2/3 multiply the numerator and the denominator by 24 gives us 48 tulips and 72 daffodils. Okay, and that's the scale factor. So that the 24 would be the scale factor. So we can guess and check. Anyway, I don't. As you can see, I ain't doing this every time. I'm going to use algebra. So this is what we know. We know there is some scale factor. Some scale factor exists. Okay? Some scale factor exists that when I multiply the numerator and denominator by that number, I will end up with another set of values that added together would give us 120. So what does that mean? What that means is that if I had 2, which is the number of tulips, times whatever scale factor it is, and I add that to 3 times whatever scale factor that is, what would we have? We would have the total number of flowers. The total number of pots is 120. Okay, so that's what this means. So what do we now know? Right? What do we now know? This is algebra. So 2 times whatever scale factor plus 3 times that same scale factor would give us the total number of 120. So what is that scale factor? The scale factor, of course, would be 24. Okay, so now we know the scale factor itself is 24. Okay, just like we did here. Which way is easier? You choose. The scale factor is 24. But that doesn't answer the question. The question is, how many pots of each type of flower should we buy? So if the scale factor is 24, that means we're going to multiply the number of tulips and the number of daffodils by 24. Okay, then we would have the ratio would still be 2 to 3, but the ratio would now be 48 to 72, which is the same ratio of 2 to 3. Okay, so we've changed nothing. We've changed nothing. All we've done is used algebra. So what does this mean? We now know we would have 48 tulip pots and 72 daffodil pots. Okay, so when we use proportions, we must understand everything from the previous lessons about ratio and scale factors and all this stuff. And that just makes your life a whole lot easier. So if you did not understand what just occurred here, it's going to be really important to watch the previous videos. Okay? So anyway, let's do another example. Here's another example, very, very similar. And I'm just going to use the algebra this time. The measures of 2 supplementary angles are in the ratio of 1 to 4. What are the measures of the angles? Now we can do this the long way if you want to try guess and check. Right? Remember, one time would be 1 plus 4. Does that equal 180? No, because by the way, supplementary, right? Does that equal 180? No, can't be that. How about 2 times? 2 plus 8. Does that equal 180? No. So guess and check. You would keep doing that, and another, 10 times even. 10 times we'd have 10 plus 40. Does that equal 180? No. So you can use guess and check. I prefer algebra. Now what do we know? We know that there is a scale factor that exists, okay? Some scale factor 1 times whatever number plus 4 times whatever number. If I multiply the scale factor to that and I add them together, I would have 180 degrees. That's because, again, supplementary, what supplementary means. So here we go. We have algebra. We have algebra on our hand. 1x plus 4x is 180. Okay, so 5x is 180. Therefore, x equals 36, yeah? So if you had guessed and checked, you'd have done 36 times. Good luck with that. But that still doesn't answer the question. That just tells us the scale factor. Okay, so the scale factor is 36. So if I have the scale factor of 36, that means I have 36 to 4 times 36. Okay, so I'm looking at 1 times 36 and 4 times 36. So I'd have 36 for one angle and then 144 for the next angle. Oh, how cool. They're both perfect squares. I love that. Anyway, so these would be the 2 angles. And to check, add them together, you get 180. So these are the angles you'd have. And that's all accomplished by understanding proportions and ratios and scale factors. Okay, so that we could use that method. Now, I think the book goes into a bunch of different stuff. I don't agree with the book so much. But anyway, I would stick with that methodology. So now we can get into something called an extended ratio. Once we've learned that, we have now extended ratios. Now, an extended ratio is where we're comparing three things. Okay, this is what we did in I think it was the first video where we had the three equal ratios, that big in proportions. This is the same thing that's happening here, but now we're going to do some geometry with it. The lengths of the sides of a triangle are in the extended ratio of 3 to 5 to 6. The perimeter is 98 inches. So what's the length of the longest side? That means when we add all these up, we get 98. What's the longest side? Okay, so the ratio is 3 to 4 to 5 to 6. Again, we can do guess and check. Okay, if you want to. So if you want to do guess and check, this is what that would look like. Okay, so we'd have, if we did it the one time, we'd have 3 plus 5 plus 6. Does that equal 98? And the answer, of course, is no. Okay, because perimeter is when we add up all three sides. And you can do it again. You know, is it 10 times, right? So we have 30 plus 50 plus 60. Is that 98? And the answer is no. It's actually bigger, so it's somewhere between 1 and 10. But that's you can do the guess and check method. Okay. I prefer we used algebra though. This means there's some scale factor, right? There's some scale factor that if I multiply it by each of these sides, according to this ratio, I would have a perimeter that is 98 inches. Okay, so I would have a perimeter that's 98 inches if I had the scale factor be multiplied. And now we can figure it out. We have algebra at play. Hooray, algebra. So we have this situation here, right? So 3 plus 5 is 8, and 6 is 14. So 14x equals 98. Therefore, x would be what? I don't know. How am I going to figure that out? Let's see. 98 divided by 14. Watch how I do this. Does 7 go into 98? Yes, it does. So 7 goes into 98. Let's see. 1 time with the remainder of 2 over 2. Oh, it's 7. That's convenient. So x is 7. We figured that out. That just means the scale factor. The scale factor is 7. Okay? So what do we do with that scale factor? We multiply by each of the sides. So our sides would then be 3 times 7, 5 times 7, and 6 times 7. Okay, so notice how important the scale factor is, which, again, the book doesn't talk too much about that, and I'm like, boo. I like scale factors. Anyway, so we have the sides of 21, 35, and 42. Does that all, when we add them, do we get a perimeter of 98? Yes. Yes, we do. Right, so 5 and 3 is 8, and 7 and 2 is 9. So we have our three sides. And that's how the extended ratio works. Very, very similar, but we're still dealing with scale factors. Same thing would occur with this one. So let me do this one a little bit quicker. So watch this. Similar question. Lengths of the sides of the triangle, extended ratio 4 to 7 to 9, perimeter 60. What are the lengths? Oh, I didn't answer the question, did I, from the previous one? What's the length of the longest side? The longest side, of course, would be 42. Cats, answer the question. Thank you. So the length of the longest side would be 42. And the next question, it's all three sides. So we do the same thing, okay? So 4 to 7 to 9. So watch how fast we can do this. 4x plus 7x plus 9x equals 60. Now why am I doing that? Because I want to find the scale factor. So 16 plus 4 is 20. 20x equals 60. X equals 3. The scale factor is 3. So I'd have 12 to 21 to 27. These would be the three sides. Okay, that's how fast you can apply this. All right? Okay. All right, on to the last little bit, which is solving proportions now. So if we remember, our first proportion that we ever investigated a couple of videos ago was 2/3 equal to 6/9. So we knew that to be true. Now there is vocabulary involved here, and we'll use this throughout the unit. Do we see the 2 and the 9? Those are called extremes. Okay, so these are called extremes, the 2 and the 9. And the 3 and the 6 are called means. Okay, so we have vocabulary. Use the same color pen. Why did I do that? Mean. That's the mean. Okay, so we have vocabulary for those numbers. We will use more of this later on in the unit, but they're called extremes and means. So why is this important? Because in a proportion, the product, which means multiply, of the extremes equals the product of the means. Okay, so we have any proportion. The product of the extremes is equal to the product of the means, which is what you guys have probably heard of before, called cross multiplication. Okay, so this is cross multiplication, cross products, whatever name we give it. It's the same thing. We're multiplying across the equal sign. Okay, so we multiply across the equal sign. Okay, we keep the equal sign, multiply across the equal sign. But we can keep it. So that's how we can figure out a proportion. And here's a couple of examples. So in example A, we have a proportion. How do we know it's a proportion? We have two equal ratios. If the goal was to solve for x, we would use cross products. We would multiply across the equal sign. We keep the equal sign, okay, and we realize that the product of the extremes, 6 and 4 is 24, is equal to the product of the means. X and 5 is 5x. Okay, so we have the cross products. So how would we solve for x? We're back to basic pre-algebra, right? We have 5x is 24, so one of the x's is going to be 24 divided by 5, right? So x equals 4.8, or leave it as a fraction, or whatever you want, right? You know what I'm saying? So we would use cross products. Now, what if you had a funky proportion like this? Like, oh, cats, settle down. This is nuts. The same thing holds true. We multiply across the equal sign. We have the extremes. Okay, so we have 3 times y, that's a y. 3 times y plus 4 would be equal to the product of the means, 9 times y. Okay, so we'd have an equation to solve there. So nice and algebra. Distributive property, 3y plus 12 equals 9y. Now we do some basic algebra. We subtract 3y on both sides, and then we divide both sides by 6. So y equals 2. So we have our solution set there. Okay, so this is how we can use cross products to solve proportions. So we can solve proportions if we use cross products. So this hopefully we've seen before, but this is in one simple proportion we can use cross products. And that is it for the lesson, folks. This is it for the entire lesson. But before we end, let's do a quick quiz. Let's see how fast we can answer some quiz questions and hopefully understand some stuff. Jessica is making a scale model of the Empire State Building. Her model will have a height of 16 centimeters. The actual height is about 448 meters. What's the ratio of her model to the height of the building? So we have the ratio of Jessica's model in the numerator to the height of the building. Okay, what was Jessica's model's height? 16 centimeters. What was the building's height? 448 meters. And how do we cancel these things out? Well, do we know that 1 meter is equal to 100 centimeters? We should know that. That is a thing that is worth knowing. Okay, so we should know that. And we use our dimensional analysis where our units cancel. And we would have 16 in the numerator and 44800 in the denominator. So we can do a quick division, and we find out that this is 1 over 2800. So it's 1 to 2800. Not the other way around, because words matter. So our solution is B. Okay, so we got to remember how the dimensional analysis works. Okay, next. Measure of two supplementary angles, ratio 4 to 5. What is the measure of the angles? They're supplementary. They add to 180. So some scale factor, when I multiply by that ratio, would give me the measure. So I plug in I find my scale factor. It turns out my scale factor is 20. So I'd have 80 to 100 would be the measure of the angles, and that would, of course, be solution C. See how fast I can go? And then the last question, In this diagram, we have x over 15. X to 15 is equal to y to 6. Y to 6. What ratio completes the equivalent proportion? X to y is equal to what? Remember how we've done this before? We can flip it on its side. X to y would be 15 to 6. So, boom. And that, my friends, is our unit, or excuse me, the lesson on ratios and proportions. So join me later. We'll get back into more stuff on similarity, but we have to build our knowledge base with algebra and pre-algebra. Take care.